Okay, so welcome back. Today we are going to start looking at control systems, and we are going to help you to understand what's going on with the control system and also with the device that it's controlling. Now, if you've ever looked at control systems or any other technical area and trying to understand it, guaranteed you will see, university professors give you pages and pages and pages of equations, and it probably will make your brain explode. We've tried not to do that in this channel. I've got over 210 videos, and I try to approach it from a perspective of understanding the conceptual, what's going on, how do things work, and leave the equations for later, because if you can get a good conceptual idea of what's going on and understand how things work, then you can hopefully generate your own equations. We're going to start out by approaching this from understanding the basics behind controlling of machines. And we're going to use as an example something you're very familiar with because it is you. It turns out that you are a really good control system. You may not know it, but every day you are a control system. So we're going to approach it by understanding how you do stuff that you do when you control machinery. And that should help you to get a very good conceptual idea of how you respond, which is how a control system responds. And we'll be able to generate a basic understanding of how the control system works. And from that, we'll be able to make a diagram and look at and make our own equations and kind of design it. And one of the things we're going to do is we're going to design a piece of software. Doesn't matter what language you use, but we're going to design this piece of software that is kind of a conceptual idea of how a control system works over time. And we're going to be able to simulate control systems of different types and have a good visual depiction, as you see here. And then ultimately what we're going to do is we're going to take this understanding of control systems and apply it in a real world situation. Now, a while back I did a series of videos on electric power systems and modeling generators, which are what generates the electricity that feeds your home or office. We looked at how those generators can be modeled in a piece of software that we developed, how the generators respond to disturbances like a sudden increase in load or a loss of load or a short circuit. We saw how this big machine, this big mechanical machine, responded to these disturbances. And what we're going to do is use this knowledge of control systems and apply that control system to the model we developed in that other set of videos, and hopefully apply disturbances and use this control system to control the machine through those disturbances to make sure that it doesn't go unstable and we can control it and keep it where we want to control it. So we're going to be talking about machinery, modeling machinery. A lot of times when you see people talking about control systems, they focus on the control system, when really I think they should be focusing on the machine that's being controlled, because you can't control a piece of machinery if you don't know how the machinery is working. What does it require? How does it respond? You need to be able to understand that in order to design a system that will control it. So we're going to start out in this video looking at some of the basic concepts behind how you are a really good control system and how you control machinery. And then we're going to be able to take that and apply it to an electronic control system and develop our own based on a knowledge of how we would do it ourselves. So let's start out with our intuitive understanding of control systems by taking an example involving you and how you control machinery. Let's say that you have a motorcycle, or it could be a vehicle, a car, whatever vehicle, and you are trying to control its speed. So here we have a picture of you on a motorcycle, and your job is to control its speed depending on what speed you want it to go to. So you're sitting on your motorcycle, up here you've got a speedometer that tells you how fast you're going, and over here on the handlebar on the right hand side you've got what's called a throttle. Let's say you're sitting still on your motorcycle. The engine is running, but you want to go 60 miles an hour. So how do you do that? Well, you look at the speedometer and it says 0. You're not going anywhere. You're just sitting there, so the speedometer says 0. So you know that you're at 0, but you want to be at 60. So right off, you know that there's a big difference between where you are and where you want to be. There's a difference of 60 miles an hour that you have to control the machine to make up that difference so that at some point you're going 60 miles an hour. So how do you do that? Well, you say, okay, I know there's a difference. So what I have to do is I have to take this throttle and I have to twist the throttle so that I get up to 60 miles an hour. Since I'm starting at 0, I know I have to accelerate very quickly to get up to 60 miles an hour. So the first thing I'm going to do is I'm going to take this throttle and I'm going to twist it like to the maximum, right? Because the way this throttle works is as you twist it, there's a wire that goes down here to the engine and it basically opens up a valve that feeds more fuel into the engine. So if I know I've got I've got to go from 0 to 60, it's going to take a lot of fuel in that engine. So I've got to open up that valve completely to get as much acceleration as possible, which means as much fuel coming into that engine as possible. So my initial response is I'm going to twist that to maximum. I don't know what that's going to give me as a final speed, but I know I've got to do a lot. So I twist it to maximum, and that's going to open up the valve, and this thing is going to start accelerating very quickly. So initially, it's full throttle, and it's going to accelerate very quickly. Now, as I get up closer to 60 miles an hour, say I'm at 50, am I going to leave that throttle at full? I'm going to say, wait a minute, I'm going kind of fast and I'm almost at 60, so I'm going to have to lay off that throttle. I don't want to twist it as far, so I'm going to have to twist it a little bit less. So I'm going to untwist it, which closes that valve a little bit, and you get less fuel coming into the engine, and your motor is going to slow down. So the closer I get to my 60 miles an hour, the less I'm going to have to twist that throttle. So ideally, if I'm at 60, I can just let go of the throttle and this thing will coast at 60 miles an hour. Now, practically, it may not maintain 60 because of wind friction and those things, but basically the idea is if I've got a big error between where I am and where I want to be, like when I'm starting at 0, I twist that throttle to maximum, and as I get closer to 60 miles an hour, I release that throttle more and more so that it is feeding less fuel. So that is the basic idea behind a control system. You are a very, very good control system. You know how to look at that speedometer, adjust the throttle just right so that you get to 60 as fast as possible. The basic control system logic is the logic that you're using. If there's a big difference between the present speed and the desired speed, give it a lot of gas. If there's a small difference, like if you're up at 55 and you want to be at 60, only give it a little gas. So that is basic control system logic that you have to implement in a control system, whether software or hardware or whatever. So in order to do that, how do we do that? Well, we need to know the present speed and we need to know the desired speed. And we need to somehow calculate the difference in our head. We know where we are, we know where we want to be, and we need to calculate that difference. The present speed in our case is from the speedometer. We can look at that. The desired speed is in your brain, whatever speed you want to attain. The difference, you do a subconscious calculation to come up with a difference. So if the speedometer says 0 and my brain says 60, the difference is 60 minus 0. So I've got a big difference of 60 miles an hour. We take that difference and we apply it to our throttle to decrease the difference. So if present speed is 0, desired speed is 60, the gas is a lot. We slam the throttle. If the present speed is 59 and the desired speed is 60, there's a very small difference. We don't want to give it much gas, almost zero gas, right? We're almost there, so give it a little bit more and you'll get to 60. So if we look at the fuel intake based on our throttle, you can see that if we start out at 0, we slam the throttle all the way to give it the most gas. So this peak amount of gas is going into the engine and our throttle is twisted to maximum. it's going to accelerate the motorcycle, and as it gets closer and closer over time to 60, the gas we apply is going to be less and less and less and less until we're going 60 and we apply almost zero. Now there's complications on that, but the basic concept is we're going to apply no gas when we're going at the speed we want to be. So the speed, as we do that, you can see we slam the throttle, we get full gas. The acceleration is maximum. It's got a lot of fuel coming in. It's going to try to accelerate as fast as possible. As we get closer and closer to the speed, the gas input is going to be less, and the speed is going to accelerate less, and it's going to finally come up to the desired speed. So this is a very, very, very common control system response, where you have the control system slamming it to get to where it wants to be, and then as it gets close to where it wants to be, you will let off on the control signal. Now, the reason why this looks like this is things take time. Our motorcycle or our engine or our vehicle takes time to accelerate. So ideally, if we could slam this and say, I want you to be at 60, ideally this would respond and instantaneously you'd be going at 60 miles an hour. In the real world, stuff takes time. You have to accelerate your motorcycle or your vehicle or your truck or whatever, and it takes time. So you now have to simulate the time it takes to slowly come up to that speed. Now we can develop kind of a logic diagram that shows what's going on with our control system of us and the motorcycle. So I've got two objects here. I've got you and I've got the motorcycle that you're controlling. If you take an input-output approach to each object, you are you, and you have coming in as an input the desired speed. You make it up in your head what speed you want to be at, and then the speedometer is another input where you look at the speedometer and it shows you the actual speed, and you have to make up your mind based on what's the actual speed, what's your desired speed, and the output of you as the controller is a throttle position. And the throttle position goes into the motorcycle. The motorcycle takes throttle position in, or fuel valve input, and it goes through and runs the engine, and the output is how many miles per hour it's going. As part of the motorcycle, you've got this feedback loop that is the speedometer, where it's got some equipment inside the motorcycle that is measuring speed, and it feeds it out through the speedometer, and you read that in. So here's kind of the closed loop control system where you've got a couple inputs, the measured speed and the desired speed. The motorcycle has an input of the throttle position, and it outputs the actual speed, and it also has an output of the actual miles per hour of the motorcycle. So here we've got a conceptual idea of what a control system does. And if you don't understand it, think about what you do if you're driving a vehicle or a motorcycle. And that can help you figure out, all of the little details about what goes on with the control system, because at the end of the day, you're the control system. What you do inside your head is you take the input of the desired speed, the actual speed, and you come up with a difference. We're going to call that the error. You want to go 60, but you're only 0, so your error is 60 minus 0. So that is the error, and that is the signal we're going to feed to the motorcycle. If it's a big error, you got to have a big signal to the motorcycle that opens up that fuel valve and causes the motorcycle to accelerate quickly. Now, something very, very, very important to understand. The signal to the motorcycle has nothing to do with speed, all right? In your head, you're taking the desired speed and the actual speed and coming up with an error in terms of miles per hour. I can't feed that number 60 miles an hour to the motorcycle. It doesn't know what that means. All the motorcycle knows is fuel valve position, right? What's the position of the fuel valve and how much fuel is coming into the motorcycle? So the signal to the motorcycle has nothing to do with speed. It's a completely different value related to fuel intake, all right? So you have to kind of decide based on that error how much fuel intake we need for the motorcycle. If I'm going 0 and I want to go 60, I know intuitively I've got to slam that valve and open the fuel valve to put maximum fuel in. Now, that doesn't tell the motorcycle to go 60 miles an hour. It just says, hey, go as fast as you can. So you have to do that, not only figure out what the error is, but you also have to figure out what that means in terms of fuel intake to the motorcycle. So you have to know 60 miles an hour means slam that throttle, right? And as I get closer, let back on the throttle and don't put as much fuel in. So you can see it's not a fixed value. You're not saying, okay, motorcycle, go to 60. You're saying, I'm just opening and closing the fuel valve, and I'm doing this in real time. I'm getting constant feedback that I always know what the actual speed is, so I can know how much to turn the throttle to give proportional fuel into the motorcycle, right? So this is time-based, right? This is real time. As the motorcycle accelerates, we're talking over time. You keep watching the speed, and if the speed is increasing towards 60, you're letting back on the throttle or closing the valve a little bit more, but you're not giving the motorcycle a fixed value. You're getting a feedback loop where you're getting, over time, you are working with the machine, the motorcycle, to come to the actual speed. Now, there's other ways to do that. You could have like a cruise control that, you set it to a fixed value and you don't do anything anymore. But we're going to look at first where we are getting a feedback and we are modulating the speed based on what we see and where we want to be. Since this has nothing to do with speed, the signal to the motorcycle has nothing to do with speed, we have to not only take that error, but convert it to a throttle position. And that's kind of an intuitive thing in our case. Like we said, if we're at 0 and we want to be 60, we know we got to slam that throttle to full to make it accelerate. So it relies on this constant feedback to modulate the speed. But our output has to be a throttle position. We're taking in miles per hour, but the output has to be some sort of throttle position that the motorcycle understands, right? Very, very important that you understand that. So the control system has a couple jobs: figure out the error and also convert that to a value that the machine can use. That's why it's really important that we understand the machine first, the thing that we're controlling, because without understanding that, you can't feed a control signal to something that you don't understand what it's doing, right? Now, also keep in mind, when we have a throttle, that throttle has limits, right? We can only twist that throttle a certain range. We can't keep twisting and twisting and twisting. It's either fully open or fully closed or something in between. So you can maybe twist it by 90 degrees, so it can go from 0 to 90 degrees or something like that. But there are limits, right? So we're going to also have to think about, what are the limits of this system? How much we can only open the fuel valve till it's totally open, or close it till it's totally closed. You can't go beyond that. So what are we doing when we're calculating this error and converting it to a throttle position? Well, we calculate the error, desired minus actual, and we're doing a controller output that is some value times the error, all right? So say this is 60, the error is 60 miles an hour, and we have to convert that to a throttle position. So the throttle position could be from like 0 to 1, we could say, where 0 is fully closed and 1 is fully open. So all we're doing is, the more the error, the higher the throttle position is. So if it's going from 0 to 1, 60 miles an hour might be a 1, and 0, if there's 0 error, we would have 0, right? So somehow we have to convert the error into something that the throttle can understand. So the controller output is going to be some value times the error, all right? Because we have to convert it from, say, 0 to 1. So from 0 to 60, we have to convert from 0 to 1. So you can see it's kind of like we talked about recently, range mapping, where you're taking one range of values and you're mapping them to a range that the machine understands. So we're taking the controller out or the machine in is some value times the error. So it's a very simple concept. You're basically taking the error and multiplying it times a number and feeding that to the machine. And A is some number proportional to throttle position. So you can see it's a very simple job we're doing. A control system, this very simple control system is basically what's the error, multiply it times a number and feed that to the machine, and the machine will respond. The important thing is, how does the machine respond? We're going to have to model that machine to figure out what it's going to do. But really, our very simple control system here just takes the error, multiplies it by some number, either greater than 1 or less than 1, and the machine will then do its job. So at the end of the day, we're going to have a control system that looks like this. And we're going to have a main controller, which is you, and you take your error, you calculate the error from the feedback and the reference. So here's our 60 miles an hour reference. The actual from the feedback is maybe 0. So the error goes into our main controller, and it's going to use some logic. We just went through some of the logic. We're going to add some logic to that. But basically, it takes the error, multiplies it times a value, feeds it into the machine, and then the machine responds by changing the miles per hour. And the first thing we're going to do is we're going to look at this machine. Again, this is the most important part of this, understanding the machine and how it works, so we know how to design our controller so that it works for this particular machine. So in the next video, we're going to start looking at the machine and building a design of the machine, how it responds over time to a control signal. And once we've got that, we can, make a simple class, or we can write some software to simulate that. And then we can look at the controller to see how it can make that machine work. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, and most of all, please let others know that we're here so we get some views. Really appreciate. Otherwise, take care and have a really good day. Thanks.